Can you guys think of a song for me to play for this next section in the book? It's a section on petroleum, and it begins on page 326 in your textbook. So follow along with me. I couldn't come up with a song, so what the heck. We're going to cover not just petroleum and how we drill it and the environmental impacts, but also talk again about ANWR. Can you remember what ANWR stands for? Jot it down and you think you know the answer, and I'll cover it when we get there. Okay, here we go. So let's get started with petroleum. First of all, petroleum is the one that you think of the most when you think of fossil fuel in terms of actually being dead organic material, right? That old line that you saw in Jurassic Park about, dinosaurs and other things that lived during the Jurassic period, and the fact that they are our oil today is true. Most of the petroleum comes from the remains of ocean-dwelling phytoplankton, and that's why we know that there's a lot of oil left to be drilled out in the oceans. The problem is we can't get to it. I mean, we have to go down too deep to be able to drill for the oil that's at the bottom or underneath our ocean bottoms. So we do drill in oceans that are shallow enough. The Gulf of Mexico is a great example. And right along our shorelines, we do some drilling because we know that there are some oil deposits there. But most of the oil in our lifetime has been drilled in Texas and Pennsylvania. And there are a few other very, very oil-rich states where we pump for them. Here are the countries that have the most petroleum. Not a surprise that Saudi Arabia is number one. It might be a surprise that Russia is number two. And that we are number three. Then there's plenty in Iran, in China, in Canada, and Mexico. I'm going to go through where we import our oil from in a little while, and you'll see that all of these countries have an important role, even Russia. And now you probably know why we make sure that Saudi Arabia is our friend, because nobody uses more petroleum than we do. However, Asia, and especially China, is catching up. When you think of petroleum, when you think of oil, we do use some oil to heat our homes up north, but mostly we're talking about refining the crude oil into something called gasoline. Also, in the book they mentioned this term. Can you name what this term means? Flaring? Flaring is something that we notice at a lot of oil rigs where there's a flame burning atop the oil rig. Why are we burning something on top of the oil rig? Well, if you figured out what flaring is, you'd know what I'm talking about. It's natural gas. Because usually where we drill for oil, there's also a natural gas deposit. And unfortunately, for the longest time, we've just been wasting that natural gas. That company is in the business of drilling for oil. They want oil. If anything else is in the way, they just get rid of it. We now know that we have considerable use for natural gas, and yet we still see flaring at a lot of the oil rigs. And of course, what are we drilling for? We're drilling for crude oil. Sometimes you hear it called sweet crude. It is the liquid oil that's really not usable for anything in and of itself, so we have to refine it into something that's usable. And here's that point that I've been making to you since day one. We only have about 40 years worth of oil left. We, the world, at current usage rates. Are we going to continue to have our current usage rate? Well, probably not. We can expect an increase in usage as more and more countries become developed and more people have more and more cars. On the other side of the coin, we can expect a decrease in our current usage because cars are becoming more fuel efficient. You know, we're getting more miles per gallon from our automobiles. You know, the biggest selling cars in America are the SUVs. We love our SUVs, and they used to be real gas guzzlers. But Detroit and the other car manufacturers have come through, and they have come up with SUVs that get much better gas mileage. Perhaps the SUV that you have in your family gets 20, 25 miles per gallon. It used to be half that, not very long ago. So you decide which one of those trends is going to win out. Will it be increased usage rate because so many more people will have cars? Or will it be decreased usage rate because we are improving our miles per gallon? This diagram shows you how we drill for oil. And again, the oil is living, organic, once living, organic material, and that's why it's called fossil fuel, that finds its way into a cavern. So really, an oil deposit is really nothing more than a big cave, but it's full of oil. And that was formed over about 100 to 300 million years ago, and it is dead material that's been under pressure. Now, it hasn't been under pressure long enough for it to become coal. That's why it's still in its liquid form. If you waited another few 100 million years, that oil might become coal. And you can see the drill rig here. This is old school. I will tell you that we have some new techniques of drilling that include being able to go horizontal. That if we discovered a big oil deposit over here, instead of building another oil derrick, instead these guys can go horizontal and they can find a way to tap into that oil reserve way over here. Well, that's good news environmentally, because now you've got one oil rig getting more than one oil deposit. Good news. Because this is habitat destruction when you have to build a new oil derrick here and you have to start drilling all over again. The natural gas, there's usually a deposit of natural gas right on top of the oil that gets drilled for. So when they're pumping the oil out, and these usually are not gushers. The things you see in old movies about gushers are pretty rare. Most of the oil has to be pumped out. It's not under pressure, and it won't just come flying out all by itself. Every now and then we do have that situation where the oil is under pressure. We relieve the pressure when we drill, and the oil just comes flying out, just like an artesian well. I think I've shown you this diagram before, but now's another time to talk about ANWR, the Alaska National Wildlife Refuge. It's always a political football, so it's worth talking about here. The reason it's a political football is we've discovered that there's oil deposits on the Alaska National Wildlife Refuge and along that coastline here. You can see it up here. So as a result of that, people that are interested in being more energy independent, they want to drill here. This diagram also shows you that Trans-Alaska Pipeline I was telling you about when I was in high school. They've built it because there are oil derricks out here in this area. Prudhoe Bay is a big drilling operation. All right, so we're allowed to drill here, and that's why they built the pipeline. Why have these oil tankers have to go all the way around through the Aleutians, all the way here to load up their tankers with oil, if we could have a one-time expenditure, build a pipeline, and then now all they have to do is pick up the oil here? And this is that area that's called Prince William Sound. What does that remind you of? What did you hear in that opening story about Prince William Sound? That's right. This is the place where the Exxon Valdez accident happened. Happened right in this region here. All right, so that's ANWR. You can see there are other places here in the United States where we have coal reserves, we have gas reserves, we have oil reserves. And then the orange is high potential. These are areas that geologists believe there's oil there, but we don't do a lot of drilling. California has a lot of oil here, and you remember the story about Santa Barbara, which is right about here. Santa Barbara's right about here. And the story where there were some in the 60s, some oil drilling platforms out in the Pacific Ocean. I believe that California has a moratorium on drilling though, and they haven't drilled any new oil. And as a matter of fact, some of the old platforms that are out there, they've sunk them and turned them into coral. They become the foundation for the buildup of an artificial coral reef off the coast of California. Here's where our main gas deposits are. And again, we have a lot of crude oil and a lot of gas deposits here along the Texas region, right near the Gulf of Mexico, and of course here in the mid-states as well. And plenty of coal. Remember, we've got like 400 years worth of coal, and you can see where we have all of our big coal deposits all around the U.S. So I think that's everything I wanted to cover on this map. If you have any questions about this map, please go ahead and ask them during class. Here's the pros and cons then of drilling in ANWR. And one of the big things that people always say we need to stop drilling is because experts say there isn't all that much oil there. Maybe 19% of our needs, and it would only last about a year, maybe 2 years. So there's too little potential oil to significantly reduce our oil imports. So the idea is, then why necessarily degrade or damage that refuge? And the reason that's a wildlife refuge, you recall from previous discussions, is because of the caribou. This is the only place that they live, and so we need to protect their herds. And you can read these other disadvantages. The cost is very high. Obviously, you have to drill way up in Alaska. Where are our refineries? Guess what? Our refineries are all down here in Texas. So even though we do a great job of getting the oil, it's got to come, even if we use the pipeline, it's got to come along the pipeline, but we still have to come all the way through the Panama Canal to get the oil to our refineries in Texas. Studies show considerable oil spills. More on that in a few minutes. But here are the advantages. It could increase U.S. oil supply and natural gas. It will reduce slightly. Sorry about this cough, everybody. Could reduce our oil imports. Of course, it would bring back jobs to Alaska. That's always a good thing. And because we are putting more oil on the market, it might lower oil prices. Probably not significantly, because the truth is OPEC, the oil producing countries, really set the price. Oil companies have already developed Alaska because of that Prudhoe Bay deal there. So, I mean, it wouldn't take all of that much extra effort to move a little bit further east and do that. And here's that new drilling techniques. It is true that there are more environmentally sensitive ways to drill for oil than the old days. So there's your pluses and minuses to ANWR. This picture here just kind of shows you how refining works. Essentially, and this probably, this might surprise you, when we have the crude oil, we have to heat it. Where does that heat come from? We have to add heat, probably burning coal, to make this furnace hot enough to take the impurities out of the oil and get the type of refined product that we need. And this diagram is going upwards to show you more and more heat needed as you go up this diagram. So probably, well, the product that we use the most also takes the most refining, and that is gasoline. Aviation fuel doesn't take quite as much refining, so you would think therefore it would be cheaper. You'd be wrong. Oil companies charge way more for aviation fuel. Heating oil, I mentioned before, has to be refined slightly, and there are some applications still up in the northeast United States where we have oil burning furnaces to keep our houses warm in the winter. It does nothing for cooling in the summer. Diesel oil, even easier to refine than gasoline. And for most of the time that diesel oil's been around, diesel fuel, it's been way cheaper than gasoline. In fact, people bought diesel engines, people bought diesel boats with diesel engines, people bought cars that ran on diesel because their fuel would be way cheaper. Well, guess what? You've probably noticed that gas pumps all around here, all around the United States, they've just decided to raise the price of diesel. So now diesel is more expensive. The explanation that I get when I ask about why diesel is more expensive than gasoline today, because it's much easier to produce. You can tell it takes a lot less heat to refine it. The reason that they raise the price is because the need for it is so limited, so the demand isn't there. You know, it's a supply and demand model. So they have plenty of supply, there's not a whole lot of demand, so they can raise prices. And they say it costs more now to get diesel to the gas station than it used to. Are you buying that? Not so sure. There are other oil-related products. Did you know that plastic has oil in it? It is basically a petroleum product. And here are some other oil usages. Candles have oil in them. Asphalt. These are very, very cheap to use, and you can probably tell if you've ever seen one of these pavers out there putting asphalt on a road, you know that that's basic, looks like it came right out of the well, oil. It hasn't been refined hardly at all. This graphic is showing you where we have all of our active drilling sites in the Gulf, and you can see there's a ton of them. Thousands of oil platforms in the Gulf. And the ones that are close to shore here, and again, this is far enough away, just so you know, this is far enough away that you can't see them from the beach, but they're out there. And some of them, rather than have the expense of using tankers all the time, have underground pipes going to connect all of these platforms, and so then the oil is pumped out of the platform and it's put in these underwater pipes. They lay right along the ocean bottom and go all the way into Texas so they can get them to the refinery. I mean, that makes sense to me. You know, why constantly have the added expense of using oil tankers when you can have the one-time expense of building, laying a nice pipeline and then using it over and over again. But just so you know, if you had any idea about how much drilling we do in the Gulf, it's big. We do a lot of drilling in the Gulf. 50 miles out was the BP Horizon. And of course, when that thing had its problem, right around here somewhere, when that thing had its problem, oil ended up going all along these coasts here and causing the same similar problems as we talked about in the opening story of the Exxon Valdez. And I'm sure you're aware of all of the issues that were surrounding those. This is some old data. And by the way, remind me in class, don't forget now, remind me in class to go to these websites for you, and I can get you some more current data. This is from March of 2011, but you can see this is just imports now, where we import our oil from. And you can see by far, this is the top 15. 87% of the oil that we import is from these countries. So you can take a look at them, see which ones are friendly to us, which ones are a problem for us. You know, when you see this list, you kind of wonder sometime when you hear the rhetoric about complaints that we're too dependent on Middle East oil, that we're at a tremendous risk. You can see Canada is our #1 importer. Mexico is 2. Well, these are both in our own backyards, and that's a lot. And then you can see Saudi Arabia is quite high. Venezuela is in our own backyard. Although that government is not all that friendly to the United States. They're more than happy to import oil to us, though, you betcha. And so those are, in fact, here's Nigeria at 900. So let's say all of these are around 1,000. They are. This one's bigger, 2,000, almost 3,000. So you can see, I've done the math for you here. These top 5 importers to our country, all of them essentially good trading partners and not much risk of big problems, you know, from a national security point of view. They give us 69% of what we import. And remember from class that we talked about today, we only import about 30% of our oil. And then here's the others. Russia, of course, problematic. Colombia can be. Iraq, of course, can be, even though they're an ally for us now since we finished the Iraqi war. Brazil's good. England's okay. Kuwait's an ally. So you get the idea. We're not at a big giant risk of having our problems. And oh, by the way, just so you know, this is 2,000, that's 2 million barrels of oil per day, to give you an idea of how much. Here's our total usage of imports per day. All right, well, I just wanted to show you that information to give you an idea of the numbers so you have some context. You know, some of these countries down here don't, you know, if they stopped importing oil to us, well, you know, we could survive. 100,000 barrels isn't nothing when you take a look at these numbers up here. And when you see 18,000 per day is what we use. Here's the last part, advantages and disadvantages of petroleum. Petroleum is an outstanding energy source for transportation because it's convenient to transport and to use. And as I mentioned in class, we have got this down to a science. It's as easy as you can ever imagine to import or to get oil. We have, we just excel at it. We have improved our processes to the point that it's as cheap as can be to get oil out of an oil well deep underground and get it into your car. It is relatively energy dense, not as energy dense as coal, but it is energy dense. Cleaner burning than coal. Nothing's worse than coal. But it does release some of these other chemicals when you burn it. So there is a little bit of lead, mercury, arsenic that comes out of your tailpipe when you drive your car. And I mentioned in class, sulfur, not so much. We've dealt with the sulfur. It still comes out of the tailpipe. Well, it still is part of the exhaust, but we trap the sulfur using something called a catalytic converter. Here's the one I want you to remember the most. Well, there's two things. Both of these things are key things to remember. The first thing is, you've got to remember that the number one disadvantage of petroleum, aside from the CO2, which is the greenhouse gas aspect, is the nitrogen. And you'll learn more about that when we cover air pollution. It's the nitrogen in the oil that still comes out of the tailpipe and contributes to something called smog. Again, we'll cover that in the air pollution chapter. The other thing I want you to remember, and I think this was addressed just slightly in the story at the beginning of the chapter. The number one oil pollution in our oceans is leaks. It's runoff from your driveway and my driveway, and from jet skis and from boats and anything else that you can imagine that runs on gasoline. Oil gets into our water ecosystems way more by those little leaks and those little runoffs than any of those big oil spills. The BP Horizon, the Exxon Valdez, any of those. This is the number one polluter of our waters. Little tiny leaks, but there's a cajillion of them. And that's why when they all add up, it equals way more oil. I think there's a statistic like 85% of all of the oil that's found in ocean water is from these little tiny leaks, not from the big catastrophes. You read about the big catastrophes, you hear about the big catastrophes, you don't hear about these little tiny leaks every single day. And you can imagine, I'm going to go back here, you can imagine if you're building this pipeline and it's lying on the bed of the Gulf of Mexico. I'm looking for my stylus here. There it is. Do you think this pipe that they built leaks a little bit? That there's a little bit of drip, drip, drip at the seam? Because after all, this pipe isn't one great big long thing. It's a bunch of sections that are welded together. Do you think some of those welds give way a little bit and there's a drip, drip, drip? You betcha. Do we know about it? No, we can't see it. It's on the ocean floor. So these drip, drip, drips happen. And you know the same thing if you go back to ANWR and we take a look at that. This Trans-Alaska Oil Pipeline. Do you think this thing drips a little? That there's drip, drip, drip here and there? Sure. Does it end up in our waters eventually? Yes. Through runoff. Key thing to remember. The big catastrophes are not the number one big problems. And I think that's about it. You got a song for me to add yet? If you can think of a song that's got oil or gas in it, tell me in class, will you? Alright, yep, that's it for oil. The next video is going to be about natural gas. And I will see you tomorrow. Take care, guys. Bye-bye.